So this video will show the solution to task 38 on the prep sheet, which is implementing this SaveSimulation subroutine. So let's have a look at what's in the program already. You will note that there is a feature to load the seeds from file, and you're given a few kind of text files to work with, one of them being cabbagepatch.txt. And if you choose that option, rather than starting the simulation with just one plant in the middle of the grid, you'll notice that there are plants and seeds, but then the seeds then turn into plants because it's spring in specified positions for you. And what might be worthwhile at this stage is probably to let's just use Notepad to have a look at the contents of cabbagepatch.txt. So it looks like this. You'll notice that the emojis are not the data is encoded differently using ASCII characters, so an S for a seed and a P for a plant. And this is basically what you are being asked to do for number 38. Rather than read the data from the text file, you need to write a function or a procedure that will write the current simulation to a text file. So let's have a look at doing this. So update the simulate 1 year subroutine so that the user is asked if they want to save the simulation. If they respond with Y, the SaveSimulation subroutine is called. Let's have a look at doing that. So inside simulate 1 year, at the end of each year, let's ask a question. Let's say save is, do you want to save the simulation? And if the response is yes, if save is equal to yes, then let's run the SaveSimulation subroutine. Let's think about what data will be needed by this subroutine. So we need to know what is going to be saved, and the thing that is getting saved to the file is the field, or the data stored inside the field variable. Let's now implement the SaveSimulation subroutine. So defining SaveSimulation, which accepts field as its parameter. We need to ask the user to enter a file name, check that the file name is valid before continuing. The file name must end in txt. Create a new file with the file name specified by the user. Iterate through each row in the field and through each column in the row. So using a nested loop like is used in the other parts of the program. And converting the plant emoji into a P and the seed emoji into an S and the soil emoji, well, that's already just a dot, isn't it? It's not an emoji. And again, don't worry about this. I kind of reordered the order of the questions because I felt like the diseased plants task was a little bit too difficult at that stage. So let's just delete that. You don't need to worry about diseased plants. So let's have a look at doing this. My first step would be to ask the user input a file name, enter a file name. Let's have a look at what prompts are. Oh, just let's use the same prompt as the read file routine. So let's say enter file name. We want to say if the file name does not end with text, then we should check, well, we should stop it from continuing. So again, that's kind of suggesting that you need a loop. While file name dot ends with text is false, again using this Python method ends with, like we did, I think we used something similar in a previous task. We want to print invalid file name must include .txt. Or let's be more specific, must end with .txt. And let's ask the user to input the file name again. So we've got a loop that will validate that the file name ends with txt instead. What else could you be asked to do regarding files? Perhaps you might need to check that the length of the file is over a certain amount. There are other things that could come up in your mock exam, so make sure you think about that. Create a new file with the file name specified by the user. So at this point, you're thinking, okay, we need to make a file. what Python function allows me to create a file is use the open function, passing in the user's file name variable as the file name. And I need to do it in a special, well, not a special, but a different mode to the other subroutine. You'll notice that the read file subroutine passes in the R parameter to the open function for reading a file. In our case here, we want to pass in the W parameter because we're writing a new file. This is creating a new file. Now we need to iterate through each row in the field. So for row in field. Now we need to iterate through each column in each row. For col in row. And we need to write S to the file to represent each plot containing a seed. Okay, so if this col is a seed, then we need to write S. And otherwise, if the col is a plant, then we need to write a P. Otherwise, it's not going to be a seed or a plant, so we just need to write what the column is because it will be a soil. So what's the next thing you need to think about? Okay, so I understand how to print text to the console. So what function or what technique allows us to output text to a file? So if I've got the file class contains, or the file object contains a write method, right? And write method will then allow me to write a string to the file at the current position. And I've got three branches to my conditional statement. One case where an S is written, one case where a P is written, one case where a dot is written. Is there anything else you need to remember? So it's all about the three steps when working with files, right? We need to open the file, we need to write to the file. Once we finish with the file, it's important to close the file in memory. Otherwise, you get issues with memory conflicts. So let's test it and let's see if it works. Let's load cabbage patch.text and run the simulation for a few years before we then save the updated state of the field. At this point, let's choose to save the simulation. Let's enter Y. Enter a file name, let's say new patch. Let's first of all try to write a file name that doesn't have the file extension, and we should see our loop running, validating that the file name must end with txt before continuing. So we solved that part of the problem. And then what do we need to do next? So it's not the same as some sort of change that just prints to the console. We can't see whether or not it's been successful. So at this point, similar to what I did at the start of the video, we need to exit the program and think about then looking for the contents of this file, new patch.txt, because this is what you will need to show as your evidence. So what mistake have I made here? Is this successfully showing the state of the field? The answer is no, because if I run the simulation again, and if I try to load the file that I've just saved with the program, we're going to see some problems. The loading of the file crashed. And you remember how the program works? It uses an exception handling statement. So try, except. If there's any problem when opening the file, it just defaults to creating a new field from scratch. So again, one of the previous tests we did was to make that a bit more clear to the user, because at this point, it's not really clear what happened. But if you have some knowledge about how the program is written, then we can see that there was some sort of problem with the file. The problem with the file is that there are no lines. We've written all of the seed data all on one line. So what we need to do is we need to make a change to make sure that each line ends with a new line, basically. So let's have a look at that. So we've got one loop. This is looping through the rows. and another loop which is looping through the columns, we want to make it so that after we've gone through all of the columns on one row, we need to write a new line character to the file. So with that small change, we should see something that works. Let's have a look. Let me just close this. So what do we need to do? Let's close the program and let's run the program again. Let's enter -1. Let's load the same test file. So the test file that comes with the program is cabbagepack.patch.txt. Let's run the simulation for a few years to see the field changing. Let's say yes to save the simulation. This time let's call it like fixedpatch.txt. And same as before, let's quit the program. Let's use Notepad to inspect the contents of the file. And this time we see that the lines in the field are separated on individual lines. Do we stop testing there? No, we probably should make sure that this data can be read by the program successfully. Let's run the program again. And now let's try to load our new file. And there's still some sort of problem. So let's think why that might be. Why is there some issue in loading fixedpatch.txt? Let's do some debugging and let's use Python to help us. So we need to make sure that there's a constant number of characters in each row. That's correct. So we've got 35, which is the value of the field width constant. And let's do the same with the rows. We've got 20, which is correct. That's the value of the field length constant. So I don't see any problems with that. So let's now try to think about what is causing it so the program can't read this data. Let's have a look at what goes on inside the read file subroutine. So something we can do to help here is not just catch, these are called like blanket exceptions. So the way that the exam board have written this code is not really kind of good Python. What we probably should do instead is to store the exception in a variable, so accept exception as E, and then what we can do is you can print the value of the exception. So it still won't crash, it will still handle the exception, but then for the purpose of testing, we can now print out some information about what caused the error, and this will help us to debug what's going wrong here. So let's have a look at that. Let's exit the Python interpreter. Let's run the program again. Let's load our file. What was it called? Fixedpatch.txt. And for some reason, this time it seemed to work. So that's weird. We weren't able to recreate the error. Is that something to do with the fact that I didn't close the file? I did close the file. So the file was closed, and then we reran the program, and we called it fixed patch. Very strange. So the reason, I'm not sure why that seemed to work the second time, but not the first time, and we weren't able to recreate the error. I'm guessing it's something to do with a memory issue on my computer, so it didn't actually successfully save the file until we exited the Python script or something. But to make it, let's just test the whole thing again just to be sure. So this time I'm just going to run the program. I'm going to say no. Let's just run the simulation. Let's say yes to save. Let's say new save test.txt. Let's now exit the program. Run the program again. And let's choose to read from the file that we just saved. New save test.txt, is that what I called it? New save test.txt. Okay, and this time it seems to work. So we weren't able to recreate that first error, I'm not sure why. But it's all working. So that was the solution to the SaveSimulation subroutine task. The idea of looping through the rows in the field and then each plot or column in the row and deciding whether or not to write the S character, the P character, or the dot character in each place, making sure to do the new line character after the inner loop so that the symbols are kind of separated by lines so it can be read.